Okay, so we are going to continue with the grade 9 geometry that we started. I think we started a while back with some grade 9 geometry. So let me just, share the live. Who is Chubby Wayne? Hello, Chubby Wayne. I hope you're good. Brown eyes with some brown skin. Okay, so guys, let's look at this. APOK knowledge. APOK and knowledge. Hello. Hello. Yeah, knowledge. How was it? Okay. If you guys can be so kind in the comment section, just let me know where you're streaming from, where you're joining from, and maybe possibly if there's anyone that wants some specific guidance tailored towards maths, then yeah, we can definitely look at some things that you would want to look at. But yeah, so just taking a moment here to look at some geometry, grade 9 based geometry. So yeah. So in a previous live lesson, we looked at some questions that have to do with this, and we went, because these are past exam questions from past papers, so we looked at questions that have to do with grade 9 geometry as it relates to these. So I'm just going to continue on then. What I did previously has been posted on my page, the YouTube channel, so if people want to check that out, they can happily check that out and watch it in their own time. But so for today, let's look at this. The diagram below is a rhombus. So we have ABCD, which is a rhombus with diagonal BD, and this is the diagonal BD. We are told that AB is extended to E, so we have AB and it's extended all the way to E. And then they say angle A is 70 degrees, which is this angle. Now, if you look at what markings we have on the diagram, there's these 1, 2, 3, 4 markings, which indicate that the sides of this rhombus are equal. Okay, and that's very important to know. Also, we are told that angle A, which is this angle, is 70 degrees. Now, this angle A was not previously in the diagram. So what I've done here is I've put in 70 degrees so that we know the angle 70 degrees is there. Okay. Yeah, once we see it, then it makes for easy calculation, and then we can be able to get somewhere. But it is so helpful to know the properties of my quadrilaterals, my four-sided shape. When I know the properties of my four-sided shapes, then it makes life easy, because this rhombus here, ABCD, even if I didn't have these markings, when I know my properties for my quadrilaterals, it makes it easy for me to be able to calculate certain things, right? And because of that knowledge, I can be able to get somewhere. So here is the 70 degrees. Here is AD being equal to AB. AD is equal to AB. Now I'm required to calculate with reasons the size of angle ADB. Okay. Michelle Steven. Is Michelle Steven really requesting? All right, let's just check here. Michelle Steven, are you truly requesting? Like for real? All right, hi Michelle. Are you requesting for real or you? Okay. All right. Requesting to stay here. Thank you. Oh, okay. I see. All right. Hopefully this is relevant to your grade because yeah. So this is obviously grade what to the grade nine geometry. So you'll just have to let me know in the comment section what it is that maybe specifically for you would like to actually look at. And thank you for the multitude of roses. Okay, so calculate with the reasons the size of angle what? So we want angle ADB, which means this angle here, right? So how would we then proceed with finding angle ADB? That angle, and look at the manner in which they have indicated the angle. Guys, this kind of notation, when they say angle, this is a symbol that stands for angle. Then if they have ADB like this, that means this middle letter D is the angle we are referring to. So when what you do is you go to A, there it is, then you say D, the middle letter refers to the angle. So they want the value of this angle, right? So look at the next question. Calculate with the reason the size of angle ADC. When they want ADC, that means ADC, which means they want now the entire angle. You see? All right. Then here, angle DBE, DBE, DBE. So now they want the angle from here all the way to there. Does that make sense? So we must be mindful of the notation, all right, but also mindful of alternative notation that they tend to use instead of this symbol, all right. They could actually alternatively say A, D, B. Sorry, the B there. This also would indicate that, you see, they don't have the symbol angle here, but they have a little cap on top of D. Okay, so the middle letter always denotes the angle that they are referring to. So it's very important for convention that we know the different manner in which they can refer to the angle. Once we know that, then we'll have no problem identifying that specific angle. I hope that makes sense. Now, we want to calculate with reasons. Now, with geometry, you need to always have a reason. And also, your reason must be in line with the reasons that are specified in a document that we called the acceptable reason document. If you know that document and you know the specific reasoning that they, as examiners are looking for specific reasoning. So even in grade 8 and 9, we can't afford to be too relaxed with how we write our reasons. Our reasons need to be on point. Okay, so let's look at, and I'm going to actually, in my life, you'll see me being actually using the reasons as per that document so that learners can become familiar with that, because as a learner in grade 8 and 9 prepares to go to grade 10, that reasoning is obviously the one approved, and in grade 12 furthermore, that is the reasoning that is basically accepted, you know, nationally by national markers. Okay, so we are now asked to calculate with the reasons the size of angle ADB. So that's ADB, like I said, that angle. So knowing this angle is 70 degrees, we know that these two sides are equal. We know that the triangle that we have here, we are going to have to use it to be able to calculate angle ADB. So what then can we conclude based on the triangle we have. What type of triangle is this? All right, given that we have two sides that are equal. All right, so hopefully in your mind you also know that this type of triangle you have here is called a isosceles triangle. Isosceles meaning there are two sides that are equal and one side that is not equal to the other two sides. So that's what we call an isosceles triangle. So given that, what do we want? We want angle ADB, this angle. So then what can we first say? We can say angle ADB is equal to angle ABD, because these two angles will be equal. Why? Because these two sides are opposite angles that are equal as well. It only stands to reason that if these two sides are equal, these angles here are also equal. All right, we call that angles that are opposite equal sides. So that's what we are going to start off with. We are going to say angle ADB is equal to angle ABD. All right. Okay, now it's no need for this double notation here. Right, so if I say angle ADB, that's fine. Angle ABD, those are equal. And the reason is angles opposite equal sides. Now, you will see me here write my reason in this manner. Angles opposite equal sides, because in the document that they call the acceptable reason document, that is the reason that is accepted or acceptable. Okay, all right, so I hope we are clear here. So I've said these two angles are equal. Furthermore, since this is a triangle, it means I can add the angles of this triangle together. So let's do that. Angle ADB plus angle ABD plus 70 degrees, which is that angle there that I've been given, is equal to 180 degrees. Now, why is that the case? Why are these three angles equal? Their sum equal to 180 degrees. Because one of three reasons that is there in that document is I can either say sum of angles in triangle, or I can say angle sum in triangle, or I can say interior angles triangle. So this is one of three reasons that you can write to support or validate why you are saying these three angles are equal to 180, because your triangle, your interior angles of a triangle, the sum of the angles of a triangle give you 180. Okay, guys, one of three of these is what is in the acceptable reason document. So you use one of these three. Okay, I would write one, of course, and I usually suggest to learners that take one and usually stick to that one that you want and use it consistently whenever you have to provide a reason for why you are adding angles, summing them to 180 inside a triangle. Now, remember we had said angle ADB and angle ABD are equal because of this reason. So that means in the place of angle ABD, I can substitute ADB. In the place of ADB, we can write in its place angle ADB, right? Because the two angles are equal, right? Plus 70 degrees equal to 180. Then 2 angle ADB plus 70 degrees is equal to 180. I can add, guys, these two together, right? I have 2 of angle ADB plus this 70 degrees is equal to 180. Then what I do is I take the 70 degrees over to the other side. I subtract. I'm left with this side, 2 of angle ADB. Then what's 180 minus 70? That gives me 110 degrees. And then, of course, 2 angle ADB if I'm going to now get the angle, I divide both sides by 2. This is solving an equation. So I'm applying my algebraic equation knowledge and I'm dividing by the coefficient so that I can then get the angle ADB. So the coefficient 2, by the coefficient, guys, I mean the number that is multiplied to the angle, which is 2. So I divide both sides by it, which means angle ADB is equal to not what's 110 divided by 2. So you guys should be able to know what 110 divided by 2 is. It is 55 degrees, and that basically brings me to the conclusion of my working. Okay, so remember, what did the question say? Calculate. Now calculate means I need to show steps on how I got to my answer. So that is why you see me first and foremost saying angle ADB, okay, within the triangle. Which triangle? Triangle ADB. In that triangle, I saw that angle ADB is equal to angle ABD. In other words, angle ADB is equal to angle ABD. Those two angles are equal. Why? Angles opposite, equal sides. Then what did I do? I added the angles, all three of them, together within the triangle. And I said they are equal to what? To 180. What's the reason? Either I can say sum of angles in a triangle or angle sum in triangle. I can say interior angles, triangle. Then I went ahead, I added, substituted in the place of ABD, ADB. Why? Because the two angles are equal. So that means in the place of angle ABD, I can have ADB. Now I have two like terms, two angles that are equal to each other. I can add these two to get 2 of angle ADB plus the 70 degrees, which is equal to 180. I take the 70, I transpose it to the right hand side. 180 minus 70, because remember, when you take a term to the other side, the positive 70 changes to negative 70, then 180 minus 70 is 110. Then you divide both sides by 2, because at the end of the day, what do you want to find? Angle ADB, which is equal to what? 55 degrees. Then what you do is you simply go to your diagram and you see that, oh, indeed, what's 55 plus 55? It's 110. What's 110 plus 70? It makes sense that these two angles together are 55 degrees plus the 70, which give you 180 for the triangle. So I've found angle ADB simply like that. What you do after that, you go ahead and you update your diagram. You write with pencil 55 degrees there, 55 degrees, so that when you go on to the next question, you're going to re-look at the diagram, asking this question, but you have updated information for the diagram that you were busy with. Make sense? Right. Can I move on, guys, to the next question? Are we comfortable? Are those who are in the live feeling like, okay, makes sense, or is there something that you'd like clarity about? Especially those who joined in literally from the beginning of the live. Can I move on to the next question? Or do we need some explanation about something? Can I get an amen in the comment section or confirmation that we are okay? Thank you, Msindo. I really appreciate the rose. It's as much appreciated this beautiful morning. Friday morning, by the way. Thank God it's Friday. Okay. All right. No comment. I think the rose was Msindo's way of saying, no, we are good. We can move on. 5.3.2. Calculate with reasons the size of angle ADC. Now, angle what? ADC. Where's ADC? Let's go. A. Do we write with reasons such as co-interior? Chire. I'm guessing Chire just joined. Yes, guys. With reasons that are appropriate. Okay? With reasons that are appropriate for the angle that you're trying to calculate. So let's look at 5.3.2. I've done 5.3.1. All right. And there was the working out. I explained that. So let's go to 5.3.2. Calculate with reasons the size of angle what? ADC. So let's go there. This is 70 degrees. We just learned now, after calculating, that's 55. But now we want the entire angle here. Okay. So we have this angle, we have 55, we are missing that angle. All right. So if we want to be able to get the entire, angle of angle ADC, it means we need to find this angle as well. All right. I hope that makes sense. So let us look at what we have. First and foremost, I hope we all can see that we have, this is a rhombus. And one of the properties of a rhombus is that the sides, the opposite sides of a rhombus are also parallel. Sides of a rhombus are what? Are parallel. So we agree first and foremost that in all truth and honesty, ABD, we did say is equal to ADB. Okay. Now, if you're looking at this problem, some of you may be thinking of something else because there's many ways to get to the answer. But I'm going to look at one of the ways. So this is a rhombus, and since it's a rhombus, it means the opposite sides are what? Are parallel. Opposite sides of a rhombus are parallel. Okay. And therefore, if that is the case, guys, okay, because we are told below is a rhombus, DC and AB are parallel. If that is the case, since I know what ABD is, remember, angle ABD, we did learn, is equal to angle ADB. And we know it's equal to 55 degrees. We had established that. That is already proved. All right. Since we knew that the two angles are equal, we found that ADB is 55 degrees. It goes without saying that angle ABD is equal to angle ADB, which is 55 degrees. That is already something we have proved in the previous what? Question. Okay. Now, that then means that CDB, this angle here, angle CDB, I repeat, angle what? CDB. So this angle will be equal to that angle. Why? I want someone to tell me in the comment section, why do we say CDB, meaning this angle, is equal to this angle? I need someone to let me know why that is the case. Why is CDB, meaning that angle, equal to ABD? ZTSRG, you are 100% alternate angles. Okay, so we are going to say CDB is equal to angle ABD, which is equal to what? 55 degrees. And the reason we are going to say alt angles, right? But not only alternate angles, we need to also state the lines that are parallel. So let's go back to the diagram. Remember, I said this is a rhombus. But one of the properties that is not explicitly indicated in the diagram, which we know because a rhombus possesses such a property, is that the opposite sides of a rhombus are what? Are parallel. So therefore that means DC is parallel to AB. So we are going to say alternate angles, and the reason why I say DC is parallel to AB. Here, let's look at this again. Angle CDB. Angle CDB is equal to what? Angle ABD. What's the reason? The reason is because these are alternate angles, and we state the parallel lines. DC is parallel to AB. Right? So someone could actually get to that point in that way. So now what do we have? That means we know this is 55, we know this is 55 degrees. But remember, we need to calculate with reasons the size of angle what? ADC. So then finishing this off, we could say the following. All right, that angle ADB plus angle CDA, all right? Add them together. We can add those angles together, okay? So angle ADC is equal to angle ADB plus angle CDB, right? So that is 55 degrees plus 55 degrees, which gives us what? 110 degrees. And there we have it. That's one way you could work out this problem. Okay, like I said, angle ADC, the entire angle, would be made up by angle ADB, which you have, which is 55 degrees, and angle CDB, which you just found out by using alternate angles. So when you add these two together, they should then give you the total of this angle, angle ADC, which is 110 degrees. One way of doing the problem. Someone else who is looking at this problem with other eyes would say, we know from the previous question, now this is a different approach altogether, that angle ADB is 55 degrees, right? Someone who knows their properties of rhombuses very well will say angle CDB is also equal to 55 degrees. But do you know what's the reason they would give? They would say diagonal of a rhombus bisect the corner angle. So it makes sense that if this is 55 for a rhombus, this is also 55 degrees. Not for the reason of alternate angles. If someone else does not see that, they would say diagonal of a rhombus bisect the corner angles. What does it mean when we say the diagonal of a rhombus bisects the corner angle? The word bisects means two. The word bi means two. Sect means to cut or to cross. Okay. So to cut into two, but equal angles. So if this is 55, this is also 55. So someone could say angle CDB, this angle here is 55 degrees. Why? Diagonals of a rhombus. So if I was someone else doing this question with a set of fresh eyes, without being influenced by what I did in the previous one, in this one, I could say angle CDB is equal to 55 degrees. And when I write my reason, according to the acceptable reason document, I can simply write diags of rhombus. Now, I know some of us would say diagonals of a rhombus bisect the corner angles. We'd write the whole thing. But in the acceptable reason document, if you write diags of rhombus, you're fine. Okay? Whoever is marking you will understand why you are saying diags of a rhombus. And this DIAGS is a short way of saying diagonals of a rhombus. Okay, so if you say angle CDB is 55 degrees and you say diags of rhombus, whoever's marking you, who knows the acceptable reason document, will understand that this is a reason that basically accommodates when someone has identified angles that are equal, that are bisected obviously in the corner, and therefore it means that they are equal, those angles. Okay, then after that, and that person would then move on and say angle ADC, which is angle ADC, the entire angle, is equal to angle ADB plus angle CDB. And then what they would do is add the two angles together and then get 110 degrees. That's someone else's approach of getting to the answer. Same answer, different approach, but at the end of the day, 100% correct. Someone else who's looking this with another set of eyes will see that we have 70, you have 55, but this entire angle and this entire angle is what we refer to as what? We refer to these as co-interior angles. This here we refer to as co-interior angles. This angle is within two parallel lines, this angle and this angle. I usually call these the armpit angles. What do you mean by armpits now? So I mean, like, if you look at your armpits, the ones that smell when you have not put roll on, if you extend your arms in front of you, all right, that would represent, your arms would represent parallel lines. Then your armpits represent the co-interior angles, all right? And what do we know about co-interior angles? The sum of co-interior angles gives you 180 degrees. Okay, so that would mean this angle and this angle together should give you 180. So what you would then do is you would say angle A, which is 70 degrees, plus angle ADB plus angle CDB together gives us 180 degrees. So let's just do that. We would say angle A plus angle ADB plus angle CDB is equal to 180 degrees. What's the reason? Co-interior angles. And then you'd state the lines that are parallel. DC is parallel to AB. Okay. Co-interior angles, we write co-int angles, and then we write a semicolon. We state the lines that are parallel. Right. So angle A we know is 70 degrees, no problem. Angle ADB is 55 degrees. CDB is what we don't know as of yet. But you see now, our priority will be to solve for angle CDB. So we're going to take everything and transpose it to the other side. 180 minus 70 minus 55 is equal to angle CDB. Then it's easy. What's 180 minus 70? 180 minus 70 is 110 minus 55 degrees gives us 55 degrees. So now I know what angle CDB is. It's 55 degrees. Guys, do you see? This is one of three ways of answering the same question, but all of these ways have different approaches. But all of them are 100% correct. And if I used this way to get to angle ADC, CDB I got now, sorry. All right, now that I have CDB, it's 55, I know. This is also 55, so then I go back. Angle ADC will be equal to angle ADB plus angle CDB. So that means ADB I already know is 55. CDB is also 55, which means in total, angle ADC, which I've been wanting, is 110. So do you see? All three of these approaches lead me to the answer, and my reasoning for all situations is on point given how I looked at the problem. So three ways of getting to the same answer, right? So that's why it's important for learners to know all these, we need to know the relationships that exist between parallel lines, because when we do, you'll be able to see alternate angles. When you know your properties of all the quadrilaterals, you'll be able to use another different approach. Okay, once again, this is a property that relates to parallel lines. Okay, so yeah, I hope, guys, for parallel lines, we know our famous acronym, UFAN. Okay, when we have parallel lines like this in geometry, there's this sort of like fun way for learners to remember parallel lines and the relationships that exist between parallel lines. And that is, if the lines are parallel, okay, on one side of this line, on top of this parallel line and on top of the other parallel line, we have what we call angles that are corresponding. We call them corresponding angles. And whenever we write the reason for corresponding angles, we need to write corresp angles and then state the lines that are parallel. So the angle on top of this line here, right, formed on one side of what we call a transversal line. This angle here on top of this parallel line. Then we go to the other parallel line on the same position on top of this parallel line, that angle. We say these two angles are equal. We call these angles corresponding angles. So I call them on top angles. Or we can say bottom of this line and bottom of the other line, the two angles correspond. We say that they are equal when lines are parallel. So that is the F shape. And the acceptable reason that we always utilize whenever we have to use the F shape, bottom, the angles are equal, top, the angles are equal, is corresp for corresponding short, and then we write angles, then we put a semicolon. We always look for the lines that are parallel. So let's say if this was CD and this was MN, I would be very specific and say corresp angles, and then I would state my lines that are parallel. CD is parallel to MN. It is of utmost importance to always state the lines that are parallel within the context of the South African syllabus that we have, which is CAPS. You must state the lines that are parallel. If you omit writing parallel lines, your corresponding angles reason does not hold water if you are going to be saying that the two angles are equal. I hope we are together there. Then we have the U shape, or what I call the co-interior angle relationship. This has to do with those armpits that I was talking about. Don't think about these being your two arms. You extend them in front of you. The arms are parallel. Then where your armpits are, those are the angles that are corresponding. that are co-interior. We call these co-interior angles. Sorry, not corresponding. So these co-interior angles, guys, would be this angle inside and that angle. All right. And I put a dot and a cross to indicate that the two angles would not necessarily be two angles that are equal, but when you add them together, the sum of those angles should give you 180 degrees. All right. So you can say that angle plus that angle is equal to 180 degrees. And whenever you have that statement written, the reason that is acceptable is co-int angles. Why co-int angles? That's the short for co-interior angles. Then please, guys, this is AB, let's say, and that is CD. You state the lines that are parallel, semicolon. AB is parallel to CD whenever you use this reason. So it's co-interior angles followed by the stating the lines that are parallel. Then last but not least, we have fun, the N for fun. We call the N shape, or sometimes they usually refer to it as Z, all right? Or Z that is slightly off the rails. But the position of the angles that we are referring to are these ones. These angles. These angles. We say these angles are also equal, right? Okay. So corresponding and these angles are also equal. We call these angles alternate angles. All right. For short, whenever we use the reason, let's say this is AB again. This line is parallel to CD. Let's say those are the two parallel lines. We write alt for short angles, and then we state the lines that are parallel. AB is parallel to CD. So guys, there are three fundamental relationships that exist between parallel lines. the corresponding angles, like I said, bottom of the same side of this line, underneath each parallel line, bottom, the angles are equal, top, the angles are equal. Please guys, corresponding, yeah, top equal, we are equal, bottom, we are equal. Then co-interior, sum of the angles equal to 180, your armpit angles. All right, you always write the reason, you state the lines that are parallel. Never ever forget to state the lines that are parallel. Then we have alternate angles. Alternate angles, your Z, your N shape if you want. Those angles in that position, we would say that those angles are equal. So if you go back then to these, the way in which I worked out the angles previously in the problems that I used, you see the use of me using co-int angles and stating the lines that are parallel when I was trying to find angle CTB, which would help me be able to determine angle ADC. And then in this situation where I used the situation of alternate angles to basically get to understanding what angle ADB was. So hopefully now we have a clearer understanding of why it's so important to know this, really such an important relationship that you need to know between parallel lines, because if you do, then it helps you a lot in being able to get certain things. Okay. If people have questions, please guys be free to ask in the comment section. If there's something you want to clarify, if there's something that you don't understand, if there's something that you want to really ask about directly, maybe you want to actually come on as a guest and ask, you can ask. If you just anything that basically does not make sense, you are more than free and welcome to ask when you feel like you need to. Right now, I can now move on. Hi Ziggy Baby. Wow, Ziggy Baby. These names on TikTok, you guys are very, very creative. So now we have 55 degrees. We have 55 degrees. We would update our diagram. We know that that's also 55 degrees. We update our diagram. We know that the entire angle is 110. Now the next question is calculate with reasons the size of angle DBE. This angle from here to there. They want us to find angle DBE. DBE. So this is from here to there. What is the size of that angle? Immediately, when you look at this problem, you have to then, have some information in your mind that will assist you to find DBE. If that information is not there, it's going to be so difficult to find angle DBE. So there's already a few things that you already know. This triangle ADB, all right, we call this angle DBE, which is angle DBE. We call this angle a what, guys? What do we call this angle here? Angle DBE is called a what of triangle DAB? Let's see in the comment section if people know what angle DBE is for the triangle DAB. What do we call DBE? What is this called in actual fact? Because AB is extended to E. So this AB extending to B, that means this is a straight line. All right. This AB continues on to BE. And this angle is formed in line with the side of the triangle. It is not inside this triangle, but angle DBE is outside the triangle. So what do we call this angle? Angle DBE. We call it a exterior angle. In other words, exterior, the word exterior means outside. Okay? And it's an exterior angle in the truest sense because AB is in line with BE. So BE is in line with the side of the triangle. So if ever a side of a triangle is in line with an external length that is produced, and the angle that we have is actually in line with the side of the triangle, we call this a true exterior angle. Now there's something that we know about the exterior angle of a triangle, and that is the following. If you have a triangle, guys, and let's say continuous with the side of the triangle. Sorry, this is probably it's not as accurate as I wanted it to be. Let me just turn over the page here so that you guys can see what I mean. Let's say you have a triangle like this, and then you have a side that is continuing with the side of the triangle. Okay, we call this here an exterior angle. And there's something that we note when we're talking about the exterior angle. The exterior angle of a triangle is equal to the sum of the two interior opposite angles. Something you need to know in geometry. The exterior angle, so let's say this is a triangle ABC, and then we have E here. And let's say this is angle ACE, angle ACE. Let me just use different notation so that you guys can see that we can also use this notation. I don't have the symbol angle here, but I have the cap on top of C to signify that I'm talking about angle ACE, this angle here. So if you look at angle ACE, we are saying that the exterior angle of triangle, which is angle ACE, is equal to what? The sum of what? Sum means the addition. But what are we adding? The two interior opposite angles. Now you want to know which are the two interior opposite angles that they are talking about. They are talking about this angle, and they are talking about that angle. Okay, so if you move from these two angles and you come to the third angle, outside that angle, that means these two added together give you that exterior angle. That's what it means. So in other words, they are saying angle what? Angle BAC and angle what? ABC. And our reason is exterior angle of triangle. We just write EXT, angle of triangle. So this is a theorem that you need to know very well as it relates to triangles. Very important. The exterior angle of a triangle is equal to the sum of the two interior opposite angles. Always, always, always. Right? But remember, the side that we say is basically making up this exterior angle. The extension of the side needs to be in line. It must be in the same straight line in order for it to qualify as that exterior angle. If it is not, then it does not qualify. All right. So when we come back here, remember we want the size of angle who? DBE, and we need to calculate giving reason. So we need angle DBE. So what is angle DBE? Angle DBE, guys, is the exterior angle. Okay, angle DBE is the exterior angle. So what do we know about it? It is equal to what? It is equal to the sum of which two angles? Angle ADB and angle DAB. So I'm going to write that down. Angle what? ADB plus what? Plus angle BAD. Or we can say DAB. It doesn't really matter, guys, as long as the A is in the middle. Angle DAB. So I'm going to say angle DAB. So these two angles. Then what do I say? Next angle of triangle. Okay. Now let's go and substitute. What's angle ADB? DB. This angle, I already calculated it. It is 55 degrees, remember? And then what's angle DAB? That's 70 degrees. It's already stated. That's 70 degrees. When I add the two together, what do I get? Let's see in the comment section if you guys are actually good in adding values. What's 55 plus 70? What is the answer that I get? 55 plus 70 is... Thank you, Shikar. Yeah. For a moment there, I thought like people are just... So angle DBE is equal to 125 degrees. Right, that's done, finished. Okay, finished. 5.3.4. Give a reason why angle ABD. Give a reason why angle ABD is equal to angle what? BDC, where BDC. Why are these two angles equal? ABD and angle what? BDC. They want us to give a reason why those two angles are equal. Why? Angle ABD and angle BDC. So they want us to find out what's the reason why these two are equal. And if you had been listening properly, you will see very easily why we say those two angles are equal. What could be the reason why we would say those two angles are equal, guys? Angle ABD and angle BDC. So why are this angle and this angle equal? The reason is, so those two angles, this angle and this angle, are equal because I'm waiting. Give a reason why angle AABD is equal to angle ABDC. So why is this angle equal to that angle? Why? Alright guys, the reason why is because remember, we know that this is a what? This is a rhombus. The two opposite sides are parallel. If the two opposite sides are parallel, all the best JB for your Olympiads today. If the two opposite sides, guys, are parallel, then that means this angle and that angle are actually equal for the reason that alternate angles, and it's because DC is parallel to AB. Okay, so I would write alt angles, and then I would state the lines that are parallel. DC is parallel to AB. That's why angle ABD is this angle is equal to BDC, that angle. Alternate angles are equal, right? So your alternate angles, and then you say DC is parallel to AB. That's why the two angles are equal. Okay. All right. So I hope that ends that beautiful case. So let's go and approach another beautiful situation here. Okay, this also has to do with parallelogram. So once again, our quadrilaterals here are of importance because if we know our parallelogram properties well, then it makes it for ease in being able to answer questions that have to do with that. Okay. So let us check this out very quickly. We are told in parallelogram, thank you, K London, in parallelogram MNOP, parallelogram MNOP, with diagonal PN. Guys, a diagonal, is a line that extends from one opposite end of a vertex of a quadrilateral to the other end of the vertex of that particular quadrilateral. That's a straight line, guys, that starts and ends on opposite ends of a quadrilateral. So that's our diagonal. So diagonal PN, we are told that MN, what's MN? MN is parallel to PO. And we are also told that MP is parallel to NO. Now the first question is, use congruency to prove that PM is equal to NO. Use what? Congruency, right? To prove what? That PM is equal to what? NO. Okay. Use what? Congruency. To prove what? That PM is equal to what? NO. So, let's go. Let's use congruency. Let us use congruency. Okay, so hopefully you guys can see how we can utilize congruency to prove that. I hope you guys can see that very well. So what we can first do is that since we know that this is a parallelogram, we've been told that, okay, explicit in the statement of MNOP being a parallelogram, one could probably say, no, PM is equal to NO, sir. But you see, the thing is, they are telling us here that we must use congruency. Now, I want, before I use congruency, to just suggest, go over, first and foremost, the cases we have for congruency. So grade 8 and 9 learners, right, and even grades that are higher, need to know all cases of congruency. We have 4 cases of congruency, 4 of them. The first one is what we call SSS. Okay. When in a triangle, let's say this is triangle ABC, let's say this is DEF. Let's say we were able to prove that AB is equal to DE, AC is equal to DF, and BC is equal to EF. Do you see that we proved one side? We've proven that for each respective side of the individual triangle, the corresponding respective sides are equal. So AB is equal to DE. That's my first S. I would say AB is equal to DE, and I would say it's given. That would be my first S. BC is equal to EF, and I'd say it's given. That would be my second S. Then I would say AC is equal to DF, and then this might be my given, and I would say that's my third S. And then I would conclude in order that a triangle ABC is congruent. Now, when you write congruency, or when you use congruency, or when you are actually stating that two things are congruent, two triangles are congruent, we use these three horizontal lines, right? So congruency is not to say equal, but congruency is to say that the sides of each respective triangle in this situation are actually the same. So we say triangle ABC is congruent to triangle DEF. When you look at the order, then the case would be side, SSS. But remember, before I even state this, before I conclude this, it would be preceded by these statements. AB is equal to DE, reason given. BC is equal to EF, reason given. AC is equal to DF, reason given. And then I'll conclude and say triangle ABC is congruent to triangle DEF. And then say side, side, side. So whenever you want to prove the congruency of two triangles, it is usually preceded by statements that basically lead us to understanding that because of these statements, we can then conclude that the two triangles are congruent. What does actually the word congruent mean? It's when you have identical things. Okay, so two identical things are referred to as being congruent. In the case of shapes, if you're talking about triangles, congruency as it relates to triangles means that you have equal sides for those two triangles and you have equal angles, all right, respectively. So that means the two objects or the two shapes are identical. They are exactly the same. You are talking about the same thing. Because the minute you have things that are equal in side and equal in angle, then it means that those two things, they are congruent. So the word congruency has to do with that. So one of the cases is side, 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 okay, that you can utilize to prove congruency. The other case of congruency, guys, is what we call a side angle side. Side angle side, it means you have proven that one respective side for the two triangles is equal, accompanied by another respective side of the triangle being equal, and then an angle that is sandwiched in between those two sides is also equal. That's why we say it's S, the first S, the two sides are equal, A in the middle. The A is deliberately in the middle because the angle that is equal for the respective triangles needs to be sandwiched in between two sides that are also have been proven to be respectively equal for the triangles. So this side and that side are equal. That side and that side are equal. That's for my two S's. I'm sorry, guys, and I'm not swearing by saying my two S's here, I'm sorry, but you get the point. The A, the angle, must be sandwiched in between the two sides. That's for side angle side. I would conclude in the same fashion that the two triangles are congruent, and then I would write my case SAS. You have to make sure that at the end you write the case of congruency to support or validate why the statements that you have mentioned above. Make sense? So first case of congruency, SSS. Second case of congruency, SAS. Third case of congruence, it's when you have still two triangles. Let's say two sides. Sorry, not two sides. One side two angles. I repeat, one side, two angles. So I usually call this one SAA, or you can say AAS. So for instance, I would say that angle is equal to that angle for reasons that are known. That angle and that angle are equal for reasons that are known. And then that side is equal for reasons that are known. And then I would conclude that the two triangles are congruent using obviously the symbol, and then my case of congruency. I can either write it this way or I can write it that way. In other words, it's two angles respectively that are equal with one side that is equal. My last case, very important case, this one, a case often overlooked and a case often misunderstood. This case of congruency is my RHS, and I need to explain that R means right angled. Right angled. Now, a right angle, guys, means an angle of 90. So that means if I can identify that right angle, then H means hypotenuse. It has to be the hypotenuse, guys. It has to be this guy, Mr. Hypotenuse. It has to be. Are we together? It has to be the hypotenuse side. And then the S, which means just another side, whatever other side it is. Okay. And guys, when I say hypotenuse, a hypotenuse is always opposite the right angle, it's opposite the 90 degrees. A hypotenuse is always situated opposite 90. Opposite 90. So I hope you guys see this. So you would say that angle is equal to that angle. That's 90 degrees. That's your right angle. Then that side is equal to that side. That's your one of the sides. And then this side, which is the hypotenuse deliberately, it must be the hypotenuse in order for it to qualify as the two triangles are congruent. Your case of congruency is RHS. If it is not the hypotenuse, then it cannot be RHS, guys. Then you need to look at one of these three. You have situations sometimes where you can have two triangles, right? And it's unfortunate the kids don't see this. You can have a situation like this where 90 is there. But then look, it's this side and that side equal, and that side and that side equal. Is the hypotenuse shown as being a side that you can identify, for equality's sake? No, because it's this side and this side. So this situation is not an RHS situation. It is a sandwiched in between, the angle sandwiched in between two sides. So it's an SAS situation, right? It's an SAS situation. It's not an RHS situation. An RHS situation is very clear, all right, because it means that the hypotenuse must be one of the identified sides. But an SAS situation, guys, is very different from that. Okay. Okay. Right. So I hope you guys understand that. Very clear. Dishonest. Okay. I think in the moment that I've actually allowed you into my live, I'm going to have to let you go, Mr. Sizwelaza. I don't know why you are writing what you've written, but you are writing it. And I don't really appreciate comments that are inappropriate in my lives, I don't tolerate them. So, yeah. And because I understand that there are many maths teachers in platforms such as this, then please do gravitate towards someone that you can actually say such things in the comment section, and you can be allowed, and there's no problem. Because you see, when you say things like that and you request, and those are things that warrant me muting you and actually possibly blocking you from my life, so that you don't actually come with that negative side of things. So please, let's keep things, let's try and be civil, let's try and be civil. So I hope those cases of congruency have been perceived. Now, thank you so much, Mr. Lecturer Yase Shalangos. I appreciate your positive comment in the comment section. That's what I need. Life is negative enough, guys. Life is negative enough. I am copying. I don't know, Mr. You're copying. Okay. All right. So this was just me explaining the respective cases of congruency. So congruency is an important concept, one that you need to personally be able to, understand well. So I just was explaining that those cases of congruency, so that as we look at the exam type question that I have in front of me, yes, just D&D, it is grade 9. So that as we look at the respective cases that I'm busy with, or let me say the exam type question, we can have this information, readily understood, so that when we do the question, we're not doing something that we don't even understand what we are doing. I hope that makes sense. So SSS, like I said, has to do with three respective sides being equal for the two triangles. SAS has to do with an angle that is sandwiched in between two sides that are respectively equal for the two triangles. Then you have SAA, if you want to call it that, or AAS. In other words, there are two identified angles that are respectively for the triangles equal, and one side that is equal. All right. For RHS, guys, like I said, for RHS, remember R means right angled, so there must be a 90 degrees for the respective triangles. We can say those two angles are equal, and we know it's a right angled. The hypotenuse must be there in order for it to qualify as RHS, and then another side. And I said here that if you have a situation where you have a right angle, but then the hypotenuse is not identified as a side, respectively, that's equal, but you have the other two sides being the two sides where an angle is sandwiched in between, then this is not RHS, but this is SAS, and we need to see it as such. We must not be confused about RHS and SAS. SAS has to do with two sides, respectively, for the two triangles being equal with an angle sandwiched in between. So this here is, even though we have a right angle, this is not RHS, it is SAS, because you have two sides, respectively equal, but the two sides have a angle of 90 sandwiched in between. So it's SAS, this one. It's not RHS. When we are clear about our case of congruency, guys, we are going to make it. Congruency is nothing. So in geometry, congruency, I don't know, think about something in your culture that is easy. It is that. Okay, so let's look at the question now, the exam type, because we've been hungry for this exam type question. The exam type question says, in parallelogram MNOP with diagonal PN, there's diagonal PN, MN is parallel to PO, okay, MP is parallel to NO. Now we are being asked to use congruency to prove that PM is equal to NO. So we want to use what? Congruence. So we are going to prove the congruency of these two triangles. Triangle WHO, triangle MPN, and triangle WHO, triangle NOP. So let's go and do that. Let's first write down the two triangles. All right. So let me just redraw the diagram here, so that at least we are working with a visual as I go along. Okay, so we are told that these two are parallel. Mr. Diagonal is written there. Okay, sorry for my imperfect drawing, but diagonal is there. I have M, I have N, I have O, I have P. Okay, then they are asking me to use a case to use congruency to prove that PM is equal to what? NO. Guys, the minute I'm able to prove that the two triangles, these two triangles are congruent, then I'll be able to conclude about MP being equal to NO. All right, so let's just relook at the question again. It says, in parallelogram MNOP with diagonal PN, I'm asked, then we are also told that MN, where's MN? MN is there, is parallel to PO. There is PO. And MP is parallel to NO. Now I'm asked to use congruency to prove what? To prove that MP is equal to NO. For how many marks? For 5 marks. So it is, I can't just say, since this is parallelogram MNOP, I know one of the properties of a parallelogram are the opposite sides are equal. I can't do that here, to prove that PM is equal to NO, because they are explicitly saying to me, please use congruency to prove that PM is equal to NO. Okay, so let's use congruence to prove that what? PM is equal to NO. So let's go. We want to prove that PM is equal to NO. So where can we start? We are going to take these two triangles. So we are going to say, in triangle MPN and triangle NOP. Okay, triangle MPN and triangle NOP. Let's go. What first can we see? We can see there that PN is equal to PN in that triangle. PN is equal to PN. Remember, we have two triangles, triangle MPN and triangle NOP. PN is equal to PN. Why? common side. That there is my S. Okay. I hope we are together then. So far, so good. Okay. Everybody in the comment section feeling the vibe, feeling the fire. Eh? I hope you are. I hope you are. Second statement that I can say, which is true for this particular diagram, is I can say angle O is equal to angle M. Angle O is equal to angle M. Why am I saying angle O is equal to angle M? Okay. No problem. Just D&D. No problem. You came a bit late. No problem. Okay. Remember, guys, that after I'm done with this, I usually save. I download the lesson. I then obviously go and upload it on my YouTube channel, so you guys can always go and check it out. I currently have a playlist for grade 8 and 9 geometry that has basically, it's filled with all the live lessons that I've done so far, up to date for term 3 for grade 8 and 9 geometry, because grade 8 and 9 geometry is similar. So I've uploaded all the videos for the live lessons that I've done. They are there. You can go and access the playlist. You can go and watch the videos in your own time when you are relaxed and you feel like you have time. It's on YouTube, so of course then you're just going to have YouTube data. If you have Wi-Fi at home, that's even greater. If you have data, you're just going to have to chow your data, and you can watch those videos, and you can watch them at your own pace, your own time. Videos are quite long, but I can tell you that they are very rich, and if you actually check them out, they can help you quite a bit. Tando Ngongoma, I do private lessons, and just contact me on the side and we can make an arrangement. Okay, so what did I say here? I said angle O is equal to angle M, right? After saying PN is equal to PN, common side, PN is a common side for triangle, both triangle MPN and triangle NOP. So I can say PN is equal to PN. It's a common side. That's my S. Angle O is equal to angle M. Why is angle O equal to angle M? Guys, opposite angles of parallelogram. We know most that the opposite angles of a parallelogram, they are equal. That's my A. All right. Then last but not least, can't we say that MPN, angle MPN is equal to what? Angle ONP. Let's look at what I was saying. MPN, this angle is equal to what? Is equal to angle ONP, that angle. What is the reason? Why can we say those two angles are equal? Why? Do we know? Can we tell? Can we say MPN is equal to angle ONP? Why? Why? Why can we say that? Okay, so hopefully we know and we can see that it's because alternate angles. Okay, alternate angles. The Z shape, the N, this angle is equal to that angle. MPN is equal to ONP. So this angle is equal to that angle. You have these parallel lines, so that means these two angles are equal. Alt angles, and we can say that alt angles, PM is parallel to ON. That is our second A. So now we have a case of congruency, SAA. All right. Okay, so I repeat again, PN is equal to PN, that's a common side. We now have angle OB being equal to angle what? Angle M. All right. And then lastly, we have MPN being equal to angle ONP. Okay. So that means really and truly those are alternate. Now we can conclude, therefore, since we have a case of congruency, side, angle, angle, we can now conclude about our triangle. And what can we conclude as we conclude about our triangle? Very easy. Very easy. So very, very important. That means PNO, triangle PNO, is congruent to triangle PNM. And then what's my case? Side angle, angle. Now, if these two triangles, guys, are congruent, it means that everything about those triangles respectively is equal. Now, because the triangles are congruent, I can conclude that PM is equal to ON, or NO as they had asked. Okay, I can conclude. So since the triangles are congruent, I can then conclude therefore that PM is equal to NO. Because remember, if the two triangles are congruent, it means they are equal in every respect. They are equal according to side, they are equal according to angle for each respective side and angle of each triangle. So I can conclude now and say PM is equal to NO. Finished, closed quote. Right? So I used congruency, guys, to prove that PM is equal to NO, and that is basically how I went about it. Maybe someone else who was doing the same question could have said, instead of using angle O being equal to M, could have said that angle MNP, meaning this angle, is equal to angle NPO, that angle. For the same reason, alternate angles. Okay, and then stated that MN is parallel to PO, so that they can then also conclude that the case is still side angle angle. Then write the congruency of the triangles with the same case of congruency, and then conclude about the sides being equal, PM being equal to NO. So all in all, guys, the cases of congruency are easy to actually be able to prove, and that helps us to then conclude about it. The minute triangles are congruent, then we can conclude and we can actually make then what? A statement with reference to the sides and the angles, because once two triangles are congruent, it means that every side, each respective side of the triangle and angle will be equal, because the two triangles are equal in every respect, both angles and sides. Okay. I want to then conclude with this problem. Okay, because congruency is a topic that we have to cover for geometry, but there's also a similarity. Okay, look at this. Okay, similarity of triangles, not congruency. Okay, so before I jump into this problem, I just want to go and read the statement of the problem so that we understand what we have. We are told here in the diagram below, okay, AC is parallel to DF. So we go directly there. AC is parallel to DF. We can see the symbolic parallel lines that are in the diagram. We are also told that AB is parallel to CF. There we have it. The characteristic parallel symbols, they are there. BE is equal to 8 centimeters. There, BE is there. We have 8. EC is 10. EC is 10. There, it's labeled, it's 10. CF is equal to 5. Where's CF? CF is 5. There, it's labeled. All right. So I'm going to go again. It says in the diagram below, AC, yeah, is parallel to DF. Always the videos are posted, guys. Right? Don't worry. AB is parallel to CF. BE is 8 centimeters. EC is 10 centimeters. CF is equal to 5. Where's CF? CF is 5. There it is. Now what are we being asked? To prove what? Triangle what? DBE is what? Similar to what? FCE. DBE similar to what? FCE. We need to prove the similarity of those two triangles. Now, before, guys, I answer this question, I want to speak a little bit about what similarity is and also provide a little bit of context into what is similarity, so that when I answer this question, you guys are not completely lost about what I'm doing. All right. Just like I did with congruency, where I explained the cases of congruency and I explained what congruency is about, so that you guys have an idea, so that when I answer the question, you are not too lost. I want to explain a little bit about what similarity is. This symbol here means similarity. It does not mean congruence. So I need to first explain a few things there. So let's come here. I want to talk about similarity. What is similarity? Okay. So when similarity, spoken in simple layman's terms, we say it is when angles are equal but the sides are in the same, we say, proportion or ratio. And I'm going to unpack this, okay? So similarity, it is when angles respectively are equal. So if you have two shapes, let's say two triangles specifically, because we know we sort of allude to similarity as it relates to triangles for the most part within our context. So it is when angles respectively are equal, but the sides are not equal, guys. The sides are in the same proportion or ratio. I'm going to unpack this proportion or ratio because in term 1, grade 8s and 9s, you guys learn about ratio. Okay? And when you speak about ratio, you define ratio as the comparison between two quantities. And I'm going to write down this definition. Ratio is the comparison between two quantities of the same type. That is what ratio is. Okay. So let's go back. What is similarity? It is when angles respectively are equal. So no one will misunderstand this part, because if angles are equal respectively for a particular shape, I mean, that's straightforward, very straightforward. But here's the idea now. The idea that basically makes similarity as well, in as much as angles respectively are equal. Because when someone says angles are equal respectively, people could easily conclude that, aren't we referring to congruency here? And then I say, no, we're not referring to congruency here. Okay? So it is when angles, for similarity, it is when angles respectively are equal, but the sides are in the same proportion. Or alternatively, I'm saying ratio. Now, we need to understand what ratio is. So in the grade 8 and 9 context, term 1, ratio, we learned about ratio. And we said ratio is the comparison between two quantities of the same type. Example, 3:5. 3:5. In order to be able to write 3:5, please understand, these are two quantities, the comparison between two quantities. They are of the same type. In other words, if I have kilometers this side, I have kilometers this side, the units must be the same for ratio. If I have x here, then I must have x
here, the units must be the same. So that's what we mean by ratio. So ratio can be expressed in this manner. All right? It can be expressed in this manner. Or I can write 3:5 as a fraction, because ratio can be expressed as a fraction. That's why we refer to a fraction like this. We call this a rational number. Hey guys, when you are lallaring you, this here, hey, ratio. And when you talk about a rational number, don't you usually say that a rational number is a number that can be written as a fraction, where the numerator and the denominator are integers, but the denominator can never be zero. So what I'm saying is that the word ratio is embedded in a rational number. So the way we can represent a ratio is we can write it in one of two formats. This is one of the formats that you can see ratio being represented in. The other format that you can see ratio being represented in is a fraction. Two formats to represent a ratio. Ratio can be represented in this format, 3:5, or ratio can be represented in this format, a fraction. Guys, I hope you are with me here. If you are flowing with me here, then you will understand what I'm saying. So I'm going back again. What is similarity? It is when angles respectively are equal. So let's say we are looking at two shapes or three. We're looking at those 3 shapes or 4 shapes or 5 shapes. We are seeing that the angles respectively for those shapes that we are looking at are equal. But what we notice about the sides is that the sides are not equal, but they are in the same proportion. And this word proportion alludes to the word ratio. What is a ratio? I'm saying ratio is the comparison between two quantities of the same type. So are you saying that when I write a ratio, the quantities must be of the same type? Yes. What do you mean by the same type? I'm saying they must be of the same unit. So if you are dealing with a ratio, 3:5, you are comparing these two quantities, but they must be of the same type. What do I mean furthermore? I mean, if for instance you are talking about distance, okay, that's one thing. It's something of the same type. 3 kilometers is to 5 kilometers. This is the same unit. That's the same type. Okay? We are not comparing different types here, okay? Because that's not ratio. When we are comparing different types, then we are talking about rate, not ratio. So this is ratio. And there are two formats in which a ratio can be represented. It can either be written in this way, or you can write it as a fraction. Now, let's move. Hey, you are moving with me. So the concept must be grasped. Now, let's come and look at something practical as it relates to ratio and similarity specifically. So, say for instance, I have this triangle. This is 60. This is 60. Let's say this is triangle ABC. This is triangle DEF. All right. So let's say this is 60 degrees. Okay. And this is also 60. And that is also 60. And let's say that is 60. And that is also 60. All right. I'm doing this very deliberately, guys. Very deliberately. Okay. So, respectively, angle A is equal to angle D. That is an angle. It is equal to 60. It is given to me. That is an angle. Angle B is also equal to angle E. Respectively, the angles are equal. That is given. That is an angle. Angle C is equal to angle F. It is also equal to 60. That is given. That is an angle. These two triangles, we would conclude and say triangle ABC is similar to triangle DEF. Why? Angle, angle, angle. Or we could say A, A, A. We could say that. This is one of the ways of proving similarity of triangle. One of the ways. If you can prove the equality of angles respectively for the two shapes, all right, for the given triangles that you have, then it means you can conclude similarity. Remember, guys, that AAA is not a case of congruence. I spoke to you about the cases of congruence. There are 4 cases: SSS, SAS, SAA, and RHS. These are the only 4 cases we have for congruence. This one here, angle, 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 is not a case of congruence. It is a way of proving similarity of triangles. When you are able to prove that respectively for all 3 angles, the angles are equal, then you can conclude that the 2 triangles are similar, and then you can actually state that it's because angle that one, angle that one, angle that one, equality of angles. So that then means equality of angles respectively means triangles are similar. Statement number 1. That's one of the ways of proving similarity of triangles. Let's look at second way of proving similarity. I want you to stick with me here, guys. Stick with me. Let's say we have this triangle. And let's say we have this one. I hope you are with me so far. This is triangle ABC. This is triangle DAF. Okay. This side here is 3. Okay. This side here is 4. And this side here is 6. This side here is 12. This side here is 16. And that side there is 24. Then I come to you and I say, prove triangle ABC is similar to triangle DEF. And then you come to me and you are like, I will but say, didn't you say to me that to prove similarity of triangle, it is when angles respectively are equal? In here, I could see angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. And therefore, I was able to prove the similarity of these triangles by using angle, angle, angle. Now, say I don't have angles here. What am I going to do? What am I going to do, say? Then I say to you, my guy, my girl, my grade 8 and 9 learner, listen to me. I said the second way. Let's go to the part, this part of similarity. Remember, I said similarity is when angles respectively are equal. Ne? But the sides are in the same what? Proportion or ratio. And then I said to you, ratio is a comparison between two quantities of the same what type. The formats in which ratio can be written is this or that. So come here, come here, come here, come here. Let us look at the ratio of the respective sides. So come here to me and let's come and look at what we have here. Do you guys see that this is AB and this is DE? So what I'm going to do, I'm going to say AB over DE. I am going to actually now use one of my formats. Because remember, if these two triangles are truly similar, what am I expecting? I'm expecting that the ratio of the sides respectively, or the proportion of the sides respectively, should be what? Equal. So my format for ratio that I'm going to be utilizing is the fraction format. And what am I going to do? I'm going to go directly to my statement where they've said I must prove the triangles. And I'm going to come here and say my first two letters, A, B, and D, E. Let us formulate a ratio using these two sides. Now someone is going to ask, sir, how do you know AB must be at the top, DE must be at the bottom? Guys, you know what? In actual fact, if you want, you can have DE at the top and AB at the bottom. But here's the thing, you must move in the same direction. And what do I mean by that? If you are going to say AB over DE to start with, then please continue in that direction. AB over DE will be your first ratio. Second ratio, you are going to say BC over EF. BC over EF. That will be your second ratio. Third ratio, you are going to say AC over DF. AC over DF. What are we doing? We are going to check if the ratios formed by these respective sides will give us equal ratios. So let's check this. What is AB? It is 3. What is DE? It is 12. For now, let's just write down all these ratios. What is BC? It is 4. What is EF? It is 16. What is AC? AC is 6. What is DF? It is 24. Ratios written. Then the next step, simplify each ratio. Now guys, in previous grades, you've been learning how to simplify for days. What is 3 over 4? 3 over 12, 1 over 4. 4 over 16, 1 over 4. 6 over 24, 1 over 4. What do you see before your face? AB over DE is 1 over 4. BC over EF is 1 over 4. AC over DF is 1 over 4. What does that mean about the sides of this triangle, respectively? Therefore, we can say triangle ABC is similar to triangle DEF. Why? Sides in proportion. Done. Second way of proving similarity of triangles. I'm going to now give people a chance in the comment section. Are we moving together? Right? As I said, I will be posting this video in my YouTube channel so people can rewatch this video when I'm done. Okay, I might post it later on today, this evening, because of situation, but I hope we are flowing together. So we can prove similarity of triangle using the sides being in the same proportion. Remember when I said similarity, what was the definition that I used for similarity? I said the definition for similarity is that angles respectively are equal. So in other words, guys, these angles can be equal respectively. You see, this side equal to that angle equal to that angle, that angle equal to that angle, that angle equal to that angle. But the sides, they are not equal. They are in the same proportion or ratio. The sides are in what? In the same proportion or ratio. And this is how we go about proving similarity of triangles. So the first way, I'm going to just go back again. Okay, we go back again. I said similarity is when angles respectively are equal, but the sides are in the same proportion. What did I say proportion is? It's same ratio. Then when we explained the definition of ratio according to what we've learned in term 1, what is a ratio? It is the comparison between two quantities of the same type. What are the formats in which we write ratio? The manner in which we can represent ratio can be like this, 3:5, or we can write ratio as a fraction. Okay. Then, if we are looking at one of the two ways of proving similarity of triangles, we can utilize the angles of the triangle, right? We can utilize the what? The angles of the triangle. If we are asked to prove that triangle ABC is similar to triangle DEF, we can look at the equality of angles in a triangle. Okay, look at A, because usually the order that they present before you is the order in which the angles should be equal. So somehow you need to be able to find that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. As you can see here, that has actually been true for these two triangles. And after you are done, you simply say triangle ABC is similar to triangle DEF, and then you write that specific reason, angle, angle, angle. Okay, that supports when angles respectively are equal for the two shapes. Then the second way in which we can prove congruency of similarity of triangles is by proving that the sides are in the same proportion or in the same ratio. What do we mean by that? It means that somehow, in some way, you need to be able to prove that for the order that they've presented to you of the two triangles being similar, AB in this order over DE should give you the same thing as BC over EF, should give you the same thing as AC over DF. And I said if you start with AB over DE and you start this side, then the numerator length should be AB. It should always be what you start with this side. You see, it's BC for this one. It is AC for this one. And then your denominator values will be for your second triangle. Then you simplify the ratios. If the ratios, guys, are the same in accordance to the order in which you saw in the statement question, then it means that the two triangles are similar. And the reason is sides in proportion. Done. Sides in proportion. Or if not, then you would have concluded and say triangle ABC is not similar to DEF if those ratios do not exhibit the same value. Okay, that's what we mean by sides being in proportion. Because guys, what would you do to this triangle to get this one? It means I am going to multiply each side by 4. That's what we mean by sides being in the same ratio. We're multiplying 3 by 4 to get 12, multiplying 6 by 4 to get 24, multiplying 4 by 4 to get 16. Vice versa, to move from this triangle to get this one, we are dividing 16 by 4 to get 4, dividing 24 by 4 to get 6, dividing 12 by 4 to get 3. That speaks to you of triangles being similar, because written in the same ratio, written in ratio format, fraction format, you can see that the ratio that we get is the same for all 3 respective sides. Go to my bio, Lutomboya. The YouTube link is there on my bio. It's also called Maths is a Game. You can actually just access it by I think it's better to actually copy the link from the bio and then post it onto your Google search engine. Then you press search there, and then it should be able to lead you to the YouTube channel. Sometimes when you click on the link directly from YouTube, it's a problem. Okay. Yeah, it's a problem. 7 days lessons. Okay, sorry. I'll check you out. See you then. Yeah. So I'm actually still yet to communicate times and what the circumstance around those people that will be joining in those session will be, Zoe. But yeah, hopefully your test didn't go too badly, given the fact that it was a short time period that obviously you had to prepare for it with my assistance and help. But I can tell you one thing, that those who have been consistently and those who I actually now have a actually working relationship with, as far as an arrangement with the parents, and also yeah, but I can tell you this one thing, that when you prepare or you are constantly doing maths on a regular, it makes life so easier, right? Because things don't become as complicated. Now guys, I was actually going to do this exam question, but due to time, I'm not going to do that. So I'm going to save this question for another time. But surely, knowing what you know now, if they are asking you to prove that triangle DBE, right, is similar to triangle FCE, it shouldn't be difficult, right? It shouldn't be difficult now, because I've explained similarity, all right? And here in this diagram, there are no angles. If there are no angles and we've been given only sides, that means we are going to be utilizing sides being in the same proportion to be able to prove the similarity of triangle what? Triangle DBE, and triangle what? FCE. Okay, so we've been given 5 centimeters here, been given 10, we've been given 8. The only problem is that we are missing, the other sides. But I think we can find those other sides using the information that has been given to us in the statements. All right, I think it's very much possible to find the sides, all right, of what we've been given. Or just maybe, it may be possible to actually find to prove the similarity of these two triangles using angles, all right? So it's something that we need to be aware of and vigilant about. But this is a formal question to prove that triangle DBE is similar to triangle FCE, and then afterwards determining the length of DB thereafter. Okay, but like I said, we need to prove the similarity of triangle DBE and the to triangle FCE. So guys, unfortunately, like I said, I'm going to have to leave right now because of time constraints. But I hope the explanation to to similarity of triangles for this problem helps you at least be able to see how you can best navigate answering this question. And I think it's very much feasible and possible to be able to answer that question with much ease. Yeah. But thank you so much. I will see you again tomorrow. My hope is that we can make this regular. Today, I actually literally was here 4:45. Can you imagine 4:45 until 6:38? It's been quite a long, lengthy lesson, but it's been rich. All right, I will be posting this onto my channel, the YouTube channel. And yes, guys, I know that the video cam quality, given the fact that it's TikTok videos directly uploaded, moving my camera quite a bit, it's up and down, this and that. I guess that's just my signature mark when it comes to this. I don't really have time to edit videos and stuff like that, but maybe in future, as things get better and as I get other resources to be able to teach and so forth, don't worry, guys, things will get better. We start somewhere and we build, we go somewhere. So yeah, definitely will be developmental and hoping to help a lot more of you. And just a reminder again, I did say that for the grade 9 learners,
that are actually going to be, that have chosen. I know some of you in your schools, forms may have come out to make your subject choice for next year, and your teachers are eagerly looking at you, especially the maths teachers. They are very, very picky when it comes to making sure that they get the right learners to go and choose mathematics for grade 10 the following year. But, I want to also help you in your journey, equip you, aid you, so that you can be the best prepared learner for next year, grade 10. So that come grade 10 next year, what can happen is that you can have ease, it can be a smooth transition from grade 9 to grade 10. So I'm intending to actually have some sessions, that will aid the grade 9 learners to be best equipped for grade 10 next year. So that come grade 10 next year, guys, something called level 7 can become a common thing for you in grade 10 next year, for all topics, for all terms throughout the whole year. Those who are already attaining level 7 should be able to actually do next year and have 100% as something that is actually like, achievable for all terms. 90%, like getting high marks like of that nature. I mean, if you're going to be losing marks, you'll be losing marks because of carelessness, not so much because you don't understand the work, but simply because you are being careless and, you just need to tighten up there and there. But all in all, it can't be that you are not answering or knowing how to tackle a question because you have no information or you do not understand. Now, in order to get to that place or that level, it requires a lot of discipline, it requires a lot of sacrifice, it requires a lot of consistency in doing mathematics. And you can only do that gradually over time. So I will be having a specific group, especially if those people are interested. I would ask that you guys do communicate this with your parents and let them know. As minor kids, you need to be able to communicate with your parents. There needs to be some level of transparency, knowing that there's this platform, it's on TikTok, there's this learner, this teacher who's assisting and aiding learners to be able to really boost their capacity to be able to really deal with the mathematical content in grade 10 next year. So if you are really someone who would want to have something like that happen for you, maybe you are here and you are not really a grade 9 learner, but your friend, your cousin, your brother, your sister, your neighbor, your cat, your dog, your whoever, but that particular individual needs something like this, then you can definitely refer them here, and I'll find some way to be able to actually ascertain who the people are who are interested, as the time approaches when I want to actually start something like this. And then, guys, we'll be working right through, even during the holiday time, we'll be doing a lot, so that what can happen then is that when you start next year, man, you'll be on another level. You will anticipate everything that will be happening. You'll be cruising. You'll be an assister and an aider to many kids in your classroom and in your school. And furthermore, that will actually boost your confidence to another level. So ultimately, it's so that you can attain the kind of marks. If you have a dream to one day become something and it requires mathematics performance that is very high, then that won't be an issue. The issue will lie with the other subjects, because of course then you will have to work on those other subjects, but it won't be an issue of maths being a problem. Even if you are attending extra classes with someone at school or whatever the case may be, you will not be under pressure or under stress because you feel like there's content gaps and knowledge that you don't have. If your teacher at school is not doing the most, you will actually be knowing the most, and maybe you will be able to actually be a help to other kids at your school, in maybe your teacher's absence, or in cases where, I know in some schools what has been happening is that maths teachers are not there, or a teacher is not there, or in the process of getting another teacher, it takes a long time, and learners are left for a very long time without a teacher. Okay, so what I want to do with this is to help with exactly that. Prepare grade 9 learners to become amazing grade 10 learners, 11, 12. Because if your grade 10 foundation is solid, I tell you this one thing, your grade 11 and grade 12 will basically be set, to go.
And obviously, we can continue with this moving on for your grade 10. I can support you guys in grade 10, support you in grade 11. We can have a WhatsApp group. Those people that specifically show that kind of interest can have a WhatsApp group. You can have direct contact with me, and I can assist you with other things, that have to do with your academic content. So that's something you need to communicate with your parents and your folks. I'll be a little bit more open as to what that entails as far as like monetary sort of like expectation. Okay, it won't be steep, it will be something quite reasonable, but I do want obviously your parent to be aware of something like that, and then if they agree, then they can actually support that initiative, and we can be on this journey together, and I can help you guys as grade 9 learners to be the best of the best when it comes to the mathematics, because it is my hope and my dream that we can assist each other in that fashion. Otherwise, guys, thank you so much. I hope you had the live session was valuable and helpful to you. I'll see you guys when I see you. Enjoy your Friday and enjoy your weekend. Bye.